Today, let's use some graphs to compare relationships. And I want you to graph more than one relationship on the same grid. So let's look at these two situations here. One situation, two graphs. Which is traveling faster? How do you know? I want you to notice in this graph, I haven't even given you scales on each axis, but you're still able to answer this question by comparing the distance to the time. So, important ideas is that a steeper graph is going to have a larger constant of proportionality. And when you have a distance versus time graph, a steeper graph is going to show a greater speed. So you can look and see that asteroid X has a greater speed than Perseid 245. It's traveling a further distance in the same amount of time. Or you could say it takes less time to go to the same amount of distance. We're going to look at this graph comparing the cost of blueberries at two different stores. So how can you tell which store has a better price for blueberries? In a situation, I want you to know that you can compare points with either the same X value or the same Y value and try to interpret their meaning. So go ahead and compare 212 versus 312. At those ordered pairs, which store has a better price and how do you know? All right. You should notice that at both stores this means you're spending $12. But at store B you get more pounds. You get 3 pounds instead of 2, so store B is a better price. All right, let's go ahead and compare 312 versus 318 where both have the same X value. In this situation, at both stores, you're getting exactly 3 pounds of blueberries, but at store B, it costs less. It's only $12 instead of $18. So again, store B is the better price. And your answers both times should match up where you've made a mistake. All right, look at these graphs again. What's the constant of proportionality for each graph? I hope you noted that store A has a constant of proportionality of 6, while store B has a constant of proportionality of 4. Remember that you're always going for the Y value whenever X is 1, that ordered pair, 1, 6, or 1, 4. All right, could you please interpret the constant of proportionality and say what it tells us about this situation? Okay, recall that it's a unit rate, and this time we're going dollars per pound. So it means blueberries cost $6 per pound at store A and $4 per pound at store B. All right, reviewing our goals, I want you to recall that the steeper graph of two proportional relationships will have a larger constant of proportionality. And also, just generally being able to compare two related proportional relationships if you place them on the same graph.